What's up? This is your all-time favorite teenage teacher. Today's class is going to focus about on geometric sequence. So geometric sequence. So a geometric sequence is one with underlying pattern of constant multiplication. So a mathematical explanation would be un plus 1 is equals to r times un. So let me break down this formula for you. So let me say you have a geometric sequence, a typical geometric sequence, 2, 4, 8, 16, and it continues like this. So what I did to the first term was I multiplied it by 2 to get my second term, and I multiply my second term by 2 to get my fourth term, the third term, and then continues like that. So let me say you want to find u2. u2 is 1 plus 1, so that means it's the same as so u1 becomes 1. So second term I had to multiply my first term by the constant ratio, so that's 2. So 2 times u1, that's 1, gives me 2. So r is our constant ratio, and the way we can find it is by simply dividing our consecutive terms. So for example, if I divide u3 by u2, I get r. That's 4 divided by 2, that's 2. So yeah, that's it basically. So important formulas you need to know and derivations. So for r, the general term, our ratio is un plus 1 divided by un is equals to un minus divided by un minus 1. So that's our general term. And our general term for un of geometric sequence is u1 times r to the power n minus 1. So you don't need to know this. You don't need to cram it in your head. It's there in the data booklet for IB SL students, and I'm sure HL too. So these are the formulas we need. So let's go to the first example that we have here. So the first example says that the geometric sequence of the first term of 81. So u1 is given to us as 81 and the fourth term of 3. So find the common difference, the common ratio, the common differences for arithmetic sequence and un, the general term. So un, the formula for un is u1 times r to the power n minus 1. So for u1 we already know it's 81, and for u4 it would be u1 times r to the power 3, because 4 minus 1 is 3. So u4 is already given to us as 3. So u1 is 81 times r3. So to calculate for r, you need to divide both sides by 81. So 3 divided by 81, that's 1 over 27. So r becomes cube root of 1 over 27. That's 1 over 3. So we have found our r. So the general term has been made easy, which is un is equals to 81 times 1 over 3 to the power n minus 1. So you can put any values of n here, and then you get the term or the value. So for the second question, we have show that the sequence with 3 consecutive terms, 75, 375, and 1875 geometric. So that's using the r formula, which is un plus 1 divided by un is equals to un divided by un minus 1. So that's like 1875 divided by 375 is equals to 375 divided by 75, you divide this, you'll get 5. If you also divide x, you get 5. Since these common ratios are the same, this proves to be a geometric sequence. And for this right here, the geometric sequence has the second term of 30. So u2 is equals to 30, and fifth term of minus 468.75. So find the common ratio, the first term and the general term. So using the this formula right here, we can simply solve this. So un is u2 in this case, that's 30. I'm going in this order. So u1, we don't know yet. You don't know u1 yet. We are supposed to look for it times r, because if you put 2 here, 2 minus 1, that's 1. So that is equals to u1r. So yeah, and then let's go to u5. We're doing a substitution. We're going to substitute one value into another. So like it should be u5 will be u1 to the power 4, r to the power 4. So u5 is minus 468.75 is u1r. So what we can do here is either substitute u1 for r or r for u1. So the easier option here would be to substitute. Let's use this equation first. So let's say u1 is equals to 30 over r. This will make our calculation easier. Instead of using r is equals to 30 over u1, let's use u1 is equals to 30 over r, because we can simply cancel it out. So 468.75 is equals to 30 over r. This is minus, this is 4. Okay, times r to the power 4. So this cancels out, this 3. So minus 468.75 is equals to 30 r3. So you have the calculators, so let's calculate for this. So when you divide minus 468.75 by 30, you get minus 15.625. So r becomes minus 2.5. If you take the cube root of this, you get minus 2.5. So u1 is 30 divided by minus 2.5. That's, I guess, is 12. It's to minus 12 actually. So to find the general term, let's make a box here since we have no place. The general term will be u1, that's minus 12, times r, that's minus 2.5, to the power n minus 1. So that should be our general term. Okay, please be going through these exercises before I do them so that you can practice. So for example 4, so we have a geometric sequence as second term of 14. So a geometric sequence has a second term of 14 and a sixth term of 224. So u6 is equals to 224. So find the possible value of the common ratio in the first term. This is exactly like what we did in the last question, in the previous question. So for un is equals to u1 times r n minus 1. So un, in this case u2, that's 14, is equals to u1r, and u6 will be u1 times r to the power 5. If this is 6, this is 5, this is 3, this is 2, so 224 times u1 times r to the power 4. So u1 is 14 divided by r. So in this, if I put it in this formula, it will be 224 is equal to u1, that's 14 over 4, times r to the power 4, this will be 3, so 224 is equals to 14 r3. So r3 is equals to, so it's like gives you r to be 2.52 actually, so 3 significant figures. The first term is 14 divided by 2.52, that's 5.55. So this example right here, okay. Our fifth example, the general term of a sequence is given by this. So that's our general term, based right here. So this is a geometric sequence. So how can we solve this? So using this formula right here to check whether it's a geometric sequence or not. So just put 5 to wherever you see n, you put n minus n plus 1 divided by un, that's 5 to the power 3 minus 4 1. Using the exponents rule, if they have the same base, you can bring this one up here. So 3 minus 4 n plus 1 minus 3 minus 4n. Remember to put a bracket since the negative sign for both. So 3 minus 4n minus 4 minus 3 plus 4n. So that's 5 to the minus 4n plus 4n, that's 0. And 3 minus 4, that is minus 1. And minus 1 minus 3, that's 5 minus 4 to the power minus 4. So since r is a constant term, since it's a constant, this is said to be a geometric sequence. Obviously there are other ways of doing this, just by simply putting values inside, and then you get the first, the second, and the third value, and after that using this un plus 1 over un is equals to un over un minus 1. I think that's simpler, so if that works for you, you can use that. In fact, for this particular question right here, instead of using the long way that I used for the previous question, let's use the simpler one so that you get the idea. So I have un is equals to 5n squared minus 2n. So let me say n starts from 1. So n is equals to 1, u1 is equals to 5 to the power 1 squared minus 2 1. So that's like 5 to the power 1 minus 2, that is 5 to the power 1 minus 2, that is minus 1. And when n is equals to 2, u2 becomes 5 to the power 4, 2 squared is 4 minus 4, that's 0 literally. Yeah. And for n is equals to 3, u3 becomes 3 squared, that's 9, and minus 6, because 2 times 3, that's so 5 to the power 3. So this really a geometric sequence. So let's find out using r is equals to un plus 1 divided by un is equals to un divided by un minus 1. So un plus 1 we have 5 to the power 3. For un we have 5 to the power 0, that's 1. And for un we also 5 to the power 0 divided by 5 to the power minus 1. This is the same as 5 to the power 3 because 5 to the power 0 is 1. So for this one, this will become 5 to the power 1. That is 5 to the power 3 is just 125, and 5 to the power 1 is 5. So these are not equal. So no, it cannot be a geometric sequence. So far in this section we have seen that the general term of arithmetic sequence is given by this formula, and the common ratio r is given by the ratio between the two consecutive terms un is equals to un divided by un minus 1, and the first term and the common ratio determine geometric sequence. So any term of the sequence is uniquely determined by u1, and the recursive definition un plus 1 is equals to r is equals to un, r times un. So often two terms not necessarily consecutive are given in a sequence. If the question specifies that it's a geometric sequence, we can plug in its given value into the equation for the general term and solve an equation system to find the first term in the common ratio. So you can be given any the value of any term in the sequence and asked to find the first term in the common ratio, and we have seen this in this. We have seen how to solve this in this video. So note that the solution is not always unique. So if a question specifies that a sequence is geometric, then you can use that the ratio of any two pairs of consecutive terms is the same. So if they ask you to prove whether this equation is a geometric sequence or not, simply use this: un divided by un minus 1 is equals to un plus 1 divided by un. So thank you for watching my video. Please give it a like, subscribe for more videos like this. Thank you.